Hello. In this video, we'll talk more about object relational mapping using JPA. So far, we've seen how to use the entity annotation to mark an entity class, meaning a class whose objects will be stored in a database. We also know how to use ID and generated value for ID fields. Fields of number, string, or date-time types do not need any annotation. They are automatically mapped to columns in a database table. These types are easy to map because relational databases also have these types. Today we'll start with two new annotations, transient, which is used to exclude a field from mapping, and element collection, which is used to map fields of collection of simple types, like a list of strings. And then later we'll see how to map fields of class types using annotations many-to-one, one-to-many, many-to-many, and one-to-one. Let's first use this class as an example and see how to use the transient and element collection annotation. To save some time, I already created this customer class with ID, name, address, and a list of strings for phones. And I have put this class inside the guestbook project that we used from last time. And this is the annotated guestbook entry class we used last time, and this time we'll see how to map three new classes starting with the customer class. So just like last time, we'll start with entity, meaning customer class should be mapped, and for the ID field, we'll do ID and the generated value. And then we have two string fields, name and address. And if we don't do anything, both fields will be mapped to database columns. However, this time, let's say we don't want to store the address field in a database, so we can mark this as transient. We'll see later that this field will be excluded. And for the list of string field, as we just mentioned, we'll map it using the element collection annotation to tell the ORM library that this is a collection of simple types, meaning string or number or date / time. So with this, before we run this class, let's see what's in my database. Right now, I don't have any tables in my database. So if we run the project, remember, because we have the property generate DDL set to true, it will automatically create tables in our database based on our mapping in the classes. So if I refresh here, now we have a bunch of tables actually. The guest book entry and the guest book entry sequence table are from the guest book entry class, and then we have a new table called customer and customer underscore SEQ table, which is used by the ORM library to generate unique IDs, so we can kind of ignore this one. So let's take a look at customer and the customer phones. So the customer table has two columns, ID and the name, and that's of course because we used the transient annotation on address, so the address field is not mapped, only ID and name. Now for the list of string field, it actually creates a separate table called customer phones, and this table has two fields, customer ID and the phones. And basically it looks like this. Now if we take a closer look, we can see that obviously the customer information is stored in the customer table, and the phone's information is stored in a separate table called customer phones. The customer phones table has a customer ID field or customer ID column, and this column is a so-called foreign key column referring to the ID column of the customers table. If we put in some data into the tables, we can see why this table structure makes sense. For example, suppose we have two customers with ID 1 and ID 2, and then we can see from the data in the customer phones table that the first three phones belongs to customer 1 or belongs to John, and the next two phones belongs to customer 2 or customer Jane. So this is how a collection of simple types is stored in a database. It's stored in a separate table with foreign keys referencing the records owning this collection. By and large, element collection is pretty easy to use, but there's one subtlety we need to be aware of, and that's the order of elements in a list. Usually when we look at data in a database table, we think of them as if they are in a fixed order, like in a Java list. But the reality is that relational databases do not preserve the order of the records for performance reasons. And that's why when we write SQL, if we want the results to be in certain order, we must use an order by clause. When it comes to mapping a Java list, if the order of the elements in the list is important, we'll have to do a little extra work. There are two ways to preserve the order in a list. If the elements are ordered in some natural order, like alphabetic order for strings, we can add an order by annotation with either ASC for ascending or DESC for descending order. If the elements do not follow any specific order, then we'll have to use an extra column just to keep the index of the elements. Mapping is still easy though. All we need to do is add an order column annotation, and the ORM library will automatically create the extra column and then use the index stored in this column to reconstruct the list when loading data from the database. For example, suppose the order of the phones is important and we want to preserve that order. All we need to do is add an order column annotation here. And if we restart the application, and if we look at the database, we can see that now the ORM library automatically creates an extra column called phones underscore order, and the ORM library will use this column to keep the index of the phones inside that list so that it will not be changed when we load the data back from the database. Okay, so transient and element collection are easy to understand. These annotations, many to one, one to many, many to many, one to one, these need a little bit more explanation. The name of those annotations actually come from the relationship types in the entity relationship model, or the ER model. ER model is a data modeling technique for designing relational databases. We don't really need to know all about the ER model. We just need to know how to identify relationship types. So what is a relationship? Well, anytime we have a class which has a field of a class type, like here and here and here, then we have a relationship between two classes. For example, here, employee class has a field of employee class type, and this gives us a relationship between employee class and employee class itself. And this relationship basically says an employee is supervised by another employee. So we can say this is a relationship between employee class, and we'll call this relationship supervised by, or whatever name we want to call it. And similarly, project class has a field of employee class type, and that means there's a relationship between project and employee. And in this case, the relationship is a project is led by an employee. So I can say this relationship is between project and employee, and we'll call it led by. And similarly, we have another field of class type. Again, this is between project and employee, and this time the relationship is a project has a number of employees being its member or participating in that project, and we can call this relationship the members relationship between project and employee. Again, the relationship name is not really important. It's just a way to distinguish between different relationships. For example, we have two relationships between project and employee, so we would want to use two different names to distinguish them, but exactly how we name them is not really important. So now you can probably see where we are going with this. A field of class type means a relationship between two classes, and if we can identify the type of the relationship, we can then use one of these annotations to annotate that field. So that's basically how it's done. The key thing, of course, is to identify the type of the relationship, which can be many to many, or many to one / one to many, or one to one. And let's first define the many to many relationship. If one object from an entity class can be related to many objects in another entity class, and if one object from the other entity class can be related to many objects in this entity class, then we call this relationship a many-to-many relationship. The important thing here is that whenever we want to identify the type of a relationship, we have to check in both directions. We take one from the left and check how many objects it can be related to on the right, And then we take one on the right and check how many objects it can be related to on the left. So knowing that, if we look at the three relationships of employee and project, we can see that the members relationship between project and employee is a many-to-many relationship, because one project can have many employees. So from left to right, one can be related to many. And one employee can be a member of many projects. So if we take one from the right and check how many it can be related to on the left, is also one and many. So combine these two together, it is a many-to-many relationship. The next relationship type is many-to-one / one-to-many. In this relationship, one object on the left can be related to one object on the right, but one object on the right can be related to many objects on the left. Note that a many-to-one relationship is the same as a one-to-many relationship. It really just depends on which one we place on the left and which one we place on the right. For example, here the relationship between E1 and E2 is many-to-one, many E1 to one E2. However, we can also say that the relationship between E1 and E2 is one-to-many, so one E2, many E1. In other words, they both mean the same relationship. That's why we put many-to-one and one-to-many together. Out of the three relationships between employee and project, the led by relationship between project and employee is many-to-one, because one project is led by one employee, and one employee can be the leader of many projects. So many-to-one. And similarly, the employee is supervised by employee relationship is also many-to-one, because one employee is supervised by one other employee, and one employee can be the supervisor of many employees. So this one is also many-to-one. And then there's the one-to-one relationship type. As you can guess, in this relationship, one object in an entity class can only be related to one object in the other entity class, and it goes in both directions. This type of relationship is not quite as common as the other two types. The example I usually use is department chair. So one faculty can be the chair of one department, and one department can have only one faculty as its chair. So between faculty and department, the chair's relationship is one-to-one. Okay, so now that we know how to identify relationship types, it's easy to add the annotations. One more thing to remember is that when we decide the relationship type, the class itself is the one on the left, and the class of the field is the one on the right. So employee and supervisor would be a many-to-one relationship, because many employee having the same employee as the supervisor. Here, the relationship between project and employee leader is many-to-one, many project having the same employee as a leader, and of course, many to many, it doesn't really matter which one is the left and or which one is on the right, but still project and employee members is many to many. One project, many members, one employee can be in many projects. So knowing that, we can quickly add the annotations. So let's say we have entity here, and we have ID generate value, and then we have supervisor. This is a many to one. And for the project, let me stop it. This one is entity. This one is, let me just copy over this. And this one is many projects having same employee as the leader, and this one is many to many. Okay, so let's run this and see what the tables look like. So refresh, and now we have the employees table, ID, address, first name, last name, supervisor ID, and we have the project table with ID, name, leader ID, and also a project members table having project ID and members ID. So again, we have a few additional tables used for generating unique IDs, the underscore, SEQ, or sequence table. So we can ignore that. But if you remember the employee project tables we use for SQL practices, you can see that this table structure is exactly like that, with the exception of some different column names. And this is indeed the correct database schema for these two classes. Okay, so by and large, again, once we identify the types of the relationships, it's not difficult to map them. With that being said, there is one more complication, and that complication is usually called bidirectional association. What this means is sometimes we have two fields in two classes referring to the same relationship. For example, we may want to change our employee class to include a field for all the employees supervised by the current employee. So in other words, we may want to add a field that contains all the subordinates of this employee. And similarly, we could add a field that includes all the projects led by this employee, and also a field that includes all the projects participated by this employee, or the projects where this employee is a member of. Now, notice that these two green fields actually refer to the same supervised relationship between employee and employee. And similarly, these two orange fields refer to the same project employee relationship led by. And these two blue fields, of course, refer to the same relationship, the membership relationship between project and employee. So basically, in class design, we can choose to represent a relationship in one class or in both classes, and both of these approaches are correct and valid designs. Now, if we decide to design our classes with bidirectional association, we do need to add a little extra for mapping. First of all, we of course need to annotate both fields in the relationship. For example, here we will need to say this one is many to one, and this one, the other end of the relationship is one to many. So many employees having the same employee as supervisor, and one employee can supervise many subordinates. And similarly, this one is the other side of this one. So this one is many to one, and on this side is one to many. And this is the other side of members relationship, and it's many to many here, and many to many here as well. So after we annotate those fields, we also need to add the map by attribute. So the ORM library knows that this relationship is already mapped by the other end. The way to specify this map by attribute is to specify the value as the property name on which the other end of the relationship is annotated. That's a kind of a long-winded way to say it, but basically this one says this relationship is already mapped by the supervisor property of the employee class. So the ORM library will look at the supervisor property of the employee class and find the other end of the relationship. So it will treat this two as the same relationship. Similarly, this one says this relationship is already mapped by the leader property of the project class. So the ORM library will look at the leader property and recognize that this one and this one is the same relationship. And the same goes for this one and this one. And here the property name is members, which is this one. So this is how we can map bidirectional association. Basically, annotate both fields, and one of them needs to say map by, and the value being the property name of the other field. Okay, so so far we have covered the annotations that are necessary to generate a relational schema, and here are a few annotations that we can use to customize the generated schema. For the most part, these annotations allow us to specify the table and the column names we want instead of using the default names like members ID or customer and so on. So these annotations are particularly useful if we already have a database and we need ORM to match the table and column names in the existing database. Now let's use an example to see how they work. Excuse me. So So when we did our SQL exercises, we used this script to create some tables, right? And we have the employees table and the projects table and project members table. And this, in terms of the schema, is basically like this one's, except that instead of employees and projects, the default name from ORM is employee, simply the class name, and project. So suppose we want to change this table names to match the ones that we used before. We can use the table annotation. So this one basically says for the generated SQL database table, I want to name it projects instead of just project. And again, let me stop the application first. And so let's quickly see the difference. For employee, of course, we'll say table name is employees. And if we compare employees with what we have here, employees has ID, first underscore name, last underscore name, address, supervisor ID. So here is ID, address, first underscore name, last underscore name, supervisor ID. So the automatically generated names are actually matching these column names exactly. So that's good. How about projects? Let's see. In projects, we have ID name and leader underscore ID, and here we have ID name leader underscore ID. So this one match as well. What about the project members? So project members, and here this one is also called project members, which is great. And we have project ID and the members ID. And here it says project ID and the member ID, so there's no S. So this is a place, I guess, we'll need to specify, we'll need to change this to say member ID instead of members ID. And that table is generated from the many-to-many relationship, and that requires us to customize the join table and join column. So the annotation looks like this. I'll say join table name is project members, and so that's this one. And we need to change this column, and this column is, so the project ID column in JPA annotation is called the join column, and this one I think is called inverse join column. So we'll have to say something like inverse join column has a name member ID, something like that. Oh, I think I missed a comma here, and this one should be inverse join columns, and this one we need to import it. Okay, so let me just manually do it here. Okay, so I think that's how it's called. Okay, so I think that should do it. yeah, if we okay, so we have a bunch of tables now, the old employee and then the new employees. I think the reason is uh, it doesn't automatically remove the old tables. So let me stop it here and let me manually drop all the tables. And let's rerun it. And let's see. And now we have the employees table, we have the projects table, and we have the project members table. And notice that now it says project ID and member ID, which is great. That means we have successfully renamed it using the drawing column annotation. So this is basically how we can use these annotations to customize a generated schema. And in this particular case, it would allow us to run this script so that we can populate the tables with some employees and projects for testing later. Okay, so moving on. Now we actually have covered all the important annotations for mapping. There are two more things I'd like to discuss, both related to how to use ORM library to access data. The first is lazy loading, and then the second is cascading behavior. So lazy loading means the ORM library automatically loads objects referenced by the current object from database. And let's use an example to see how it works. So let's say that we want to display a project and members of the project. And to do that, let's first run the script to insert a few objects and employees. And now if we select employees, we see John, Jen, and Tom. And if we select projects, we see the 3 projects. And if we look at project members, some projects have some members. So again, when we did our SQL exercises, we used these tables. Now let's actually write some code to display them. The first thing I will do is to create a project repository because I want to display a project. And by the way, in the last video, I made the mistake of labeling the guestbook entry repository, and this is unnecessary because this is an interface, and an interface cannot become a bin. What happens is actually Spring Data will create an implementation of this interface, and that implementation becomes a bin, and we don't need to annotate this one with a repository because the implementation becomes a repository bin. Anyway, so let's do the same thing, but this time we are going to do it's not a class, it's an interface. And this one we'll call it project repository. And the project repository will extend again prod repository, but this time the the class type is project, and the ID type is still integer. So I think this should do it. Okay, so now we have a repository, and let's go here, and now we need to inject that into the controller. So we'll say project repository, project repo. And project repository, project repo. Let's project repo. Something like that. Okay, and then let's create a handler method, and I'll say get map, and we'll say project ID, and we'll say project, I guess, and this one. And we also need a model, and here we'll say model add attribute. We're going to use project repo to find by ID, I guess. Find by ID, which is this ID. And very importantly, find by ID returns optional, and we'll need to do something like this. We'll say or else, and this will ensure that the optional gets converted into a project object and pass it onto the view. And the view, let's just call it object. Okay, so yeah, and then let's quickly create a view. Where is it? Let's do HTML, and this one will be called project, and HTML. And here, let's just show the project name first. Let's make sure the thing works. Okay, and yeah, let's run it. And refresh, nothing here, but if we go to project 1, we get Firestone, which is indeed project number 1. And if I go project 2, it's blue, which is indeed project number 2. Okay, so this part is not anything special in the sense that we are, where is the controller? In the sense that we are doing project repo find ID and find a project. So finding a project and get a project name, that's not surprising at all. So we should get, project ID, name, and employee leader, in fact. Now, the lazy loading part is when we try to access the members. So notice that members information is stored in the employees data table, right? And to go from projects to employees, we actually has to go through project members table as well. In other words, if we have to do this in SQL, it's going to be a 3-table drawing. However, here we don't need to do any drawing at all. In fact, all we need to do is simply say, let's list the members, and we'll do list project members. So that's the property, right? Right. The property is called members, and as member, and for each member, we'll say member first name and member last name, and yeah. Okay, so if we do this and we refresh, we can see that this one actually automatically gets us John Doe and Jane Doe. And if we verify it for project number 2, indeed, John Doe and Jane Doe are on project number 2. If we change this to 3, it will only show Jane Doe because only Jane Doe is on project number 3. So this is the benefit of the so-called lazy loading, meaning that the application first load a project, and then later on, when we try to access the members of the project, the ORM library will actually run additional queries to load those data from the database instead of we having to do it ourselves. So this is, of course, quite beneficial in the sense that it simplifies code a lot. Instead of doing a 3-table drawing by ourselves, we really don't need to do anything extra. We simply use the fact that these members are referenced by the project, and we simply use them, and the ORM library loads them for us. So yeah, in summary, lazy loading is pretty useful, and it's also the default behavior, so we don't need to do anything extra to enable it. And then there's something called cascading behavior. This determines whether an operation on a parent object should be applied to the children object. So let's take this for example. Suppose we have a bank application with a customer class and an account class. What exactly in each class is not really important. For this example, let's just say that the customer class has a list of accounts representing the accounts this customer holds in this bank. Now, suppose a new customer comes to the bank and opens 2 accounts. The code may look like this. We first create a customer object, then 2 account objects, and then add the 2 account objects to the list of accounts in the customer object. And then we call customer repository to save the customer object. Now, here's the question. Now, when we save the customer object, will the 2 accounts object be saved as well? And similarly, we could have a situation where we want to delete a customer object, and the question becomes, should the accounts owned by this customer be deleted as well? Or in other words, should the delete operation be cascaded to the account objects? The JPA standard defines several so-called cascading types. We look at the documentation. These are the cascading types: detach, merge, persist, refresh, remove. These are basically operations. And then there's an all type representing all the operations. So in JPA, if no cascading type is specified, then no operation will be cascaded, meaning that if we don't do anything, then when we save a customer, the accounts objects will not be saved. When we delete a customer, the accounts objects will not be deleted. In other words, nothing gets cascaded. However, if a cascading type is specified, that means the operation represented by that cascading type will be cascaded. So here are a couple of examples. The first one basically says we want to cascade persist operation and merge operation to the accounts objects. And the second one basically says we want to cascade all operations. Now, in JPA, there are two types of save operations. Both persist and merge have perform a save operation with somewhat different mechanisms, but by and large, both of them are safe. So it's usually safe and often actually makes sense to cascade these two operations. On the other hand, we probably don't want to cascade all operations because all would include the remove operation, and if we cascade remove, we may accidentally delete data that we want to keep. So if we want to cascade, oftentimes we'll cascade, persist, and merge. So now that we know what cascading means, let's quickly see an example. Hopefully I can do this example. Yeah, quickly. So in this example, I want to show that we want to add a new employee to a project, and when we save that project, we want to see whether this new employee gets saved or not. Since we will be adding a new employee, the thing I want to change first is actually this employee sequence table. So notice that in this employee sequence table, it says the next value is 1, meaning that the next unique value generated by the ORM library is 1. However, we already have 1, 2, 3. The ID 1, 2, 3 are already used by the data here. So what I want to do is I want to change this to, let's say, 100. So in other words, the next employee added will have the ID 100 to avoid conflicting with existing IDs. Okay, so having done that, let's quickly implement add member operation. So what we'll do is we'll say project and ID and add member, and we'll do add member. And so yeah, we don't even want to create a view, so we don't need the model thing. Here, what we do is we what do we do here? Okay, so we'll create a new employee. So we'll say new employee, and we'll give it first name, last name, doesn't really matter, and we'll call this employee, let's say Tom Smith, for example. And Smith. Okay, and then what we do is we get a project, and this project is project repo find by ID, and then we add this new employee to members. Yeah, great. And then we will save project. We'll save project repo, save project. And then we redirect back to project ID. Yeah, something like that. Okay. So the thing here, as we can see, is that we are creating a new employee, and instead of using employee repo to save this employee first, we actually try to save the project. And knowing cascading behavior, we actually expect that this new employee will not be saved because we didn't specify any cascading behavior, so the save operation should not be cascaded to the employee object in members. But let's see how whether this thing how this thing works. So I'm going to run this. And I'll go to add member. Is it called add member? Yeah, it's called add member. And it gives us an exception. So if we look at the exception here, it says object references an unsaved transient instance. And it asks us to save the transient instance it it asks us to save the transient instance before flashing, and this transient instance is an employee object. Right? So this is basically what we expect because the employee object is not saved, and when we try to save the project, we get a warning that this employee object is a new object, and we cannot save project. So what we do here is we will add cascade here. So we will do something like this. We will say cascade, persist, and merge. So what this one means is that when we save a project object, then the save operation should be cascaded into the list of employees. So if there's any employee object in this list that needs to be saved, they will be saved as well. So let's see what happens if we do that and run. And let's refresh this. So we are going to project number 3, and let's do add a member here. And now we actually added this new employee, Tom Smith. And of course, the difference between now and then is we have the cascading behavior specified here. So the save goes into the members and save that new employee object. And if we look at here, we can see that this new employee object is saved. And but surprisingly, the ID it takes is 51. I was expecting it to take 100. Yeah, whatever. It's I guess it depends. It has something to do with the internal algorithm used by Hibernate to select the next ID. But as long as it doesn't conflict with existing IDs, I'm fine with that. Okay, so that's about it for today. This is how cascading types works, and today we have covered all the important annotations plus lazy loading and cascading. All right, that is it for today. Thank you, and see you in the next video.